So just like if you remember, kind of like why do we have Docker, right, in the first place? The idea is, before Docker, we had these virtual machines, right? So, and you can kind of ensure that the proper environmental setup occurs if you basically start from scratch, meaning start with the operating system. And you get this degree of isolation. You make sure the environment is set up step by step, but it has this problem, which is just it's a lot of resources to have a separate virtual machine. It consumes space to do that. Consumes just like CPU power to do that. So the idea is like, can we actually just like share some of these resources, but still get this degree of isolation and make sure there are not conflicts. So the main way that Docker does this, right, is with this union file system, where like with the union file system, you can share. It has two features. One is that we can have our files live in different folders, but it appears as if they live in the same folder. All right, so even if they live elsewhere, we can have it appear as if they live in the same folder. And that's this example of this actually lives in a CD, this is on the hard drive, but it lives, all of it, but we, have them look as if they're both under the same Harry Potter books folder. The second feature, probably even more critically, is this copy on write feature, where like if we need to make a change, we are not actually making a change, but instead we're first copying what we want to change and then editing the copy and leaving the underlying layer untouched. And the reason why this is important is because this means we can share, resources across, really, like with Docker would be different images, right? And that we can share resources across different images. When a file is changed, it's not going to affect that image that relies on it, right? Where instead we're just going to make a copy of the page or whatever, or the file, and that's where the change will occur. So we can just ensure, like, okay, we can share software or these files, and if something needs to modify it, it won't actually modify it. It will make a copy and then modify it. And we said, like, when we talk about images and containers, remember the analogy is essentially like the image is, you downloading VS Code, right? And the container is now you're booting up VS Code and it's actually running, right? So the container is like the running of the software, and the image is downloading it, or like the actual files. So when you boot up a container, it's the same thing. Everything here is not actually persisted. If if we boot up our Ghost app and we create a blog, it won't change any of the underlying data structure. Even if you save it, things like that, it won't alter the image at all. Any changes that it made will be made, first we'll make a copy of the file and then save it, and just alter that copy. This also means that, like, and this kind of gets into the next lesson, anything that you change in the container is not going to be persisted. All right? So we're going to see that, that it's not going to be persisted. If we want it to be persisted, right, we're going to have to do something a little, we're going to have to configure it a little bit differently. So, you kind of get used to that. But for right now, right, just remember, like, what's an image? Image is, okay, we downloaded VS Code, we unzipped it, right? Like, those files on our computer, that's an image. Container is, we're booting that up, right? And we gave that analogy of kind of like the process, right? A container is designed to feel like a process, right? Other things just to pay attention to is Docker also just makes sure that there's isolation of the processes. So we saw that if we boot something up like Ghost and it says it's running on this port, it's running on the port inside of the container. But if you want to get access to the port, you have to say, okay, a port on the host computer points to a port inside the container. All right? So it's like you have to kind of connect the port. So we can do that. If I do this Docker image ls, we can see the various images I have on my computer. There's actually an image for like Jupyter. Like we can boot up Jupyter. So if I do Docker run, and how would I have cloned this? I did Docker pull, and pulled it down, and now I can do docker run and run Jupyter SciPy Notebook. So ultimately, this is going to be the same thing. Like, it says it's running on port 8888, but it actually isn't, right? This is the port inside the container. So how would I fix this? Remember, I'll have to do docker run -p, and then it's the host port, so that'll be 8899 colon, and that's going to point to the container port of 8888. And now if I boot this up, one thing just to pay attention to, gang, like if you just do command click and then you change this, you have to make sure that this token matches what it has over here. So in this case it does, but so we are kind of good, but just make sure of that. I don't really have, lots of times the convention, I always ask, is there a convention for choosing ports? Yeah, normally the convention is actually that you'll just map the port to the same one it is in the container. So normally you'll just do 8888 points to 8888. I choose a different one more for teaching to show you that this one on the left is the host computer and this one on the right is the container, right? And it says an issue, but so again, I'm going to copy this. You just copy this, and it has the token in there. The token will probably change each time. And then I just have to change this value right here, this port, to 8899. I think that should work. Yeah, this is looking good. All right. So if this boots up, you can imagine, right? This boots up in Docker, Jupyter, just like the same way we booted up Ghost. And now if I create a new file here, like have this untitled and say like hello world, if I spell it right, just remember that none of this is going to be saved, right? And the reason why is because remember we have this image and then we have this writable container, but any changes we make are not going to be persisted to the image, right? There's nowhere to save it. The whole process is copy on write, and so when we boot up the image again, nothing we do is actually going to affect the image. And this is by design, right? Because if I make a change, accidentally, we don't want this to affect the underlying image. The whole point is to have this automated, like full fail-safe process where the image is the image, right? And we're not so easily able to change something. So, okay, so if I shut down my container, let's just see that, and I boot this up again, right? Remember that I created that Jupyter notebook, and I put in hello world there, but now if I go back to 8899, it's gone, right? We're back from scratch. So again, the reason why is because you can imagine this top layer basically disappears the minute we shut down the container. So then the question is, of course, like, well, how do we actually persist any changes, right? You can imagine, like, with Ghost, if we wrote out a blog and we want to use Docker, like, how are we going to save that somewhere? So Docker, of course, like, gives us a way to do that. And the first way is with bind mounting, all right? So the way this will work is that I'll show you something. So when we boot up this notebook, this is actually, let's do it real fast. When we boot up this notebook, right, this is let's take a look at which directory we're writing these files to. So I'll go to 8899 again. And then I can go here, let's create a new notebook, I'll type in pwd. So you can see that this notebook, untitled, is in home Jovian work, right? And if you remember from like later on Sunday, we can kind of see that. If I do docker ps, here's the container running. I guess Ghost is still running somewhere. And then I can do docker exec -it, the name of the container, right? So I'm going to execute a command against the container, bash, right? And run the bash command against this container. All right, and press this. And remember the IT is to like stay connected. And I'll do ls pwd, home, Jovian, here's work. Inside work is this untitled, right? So this is what we're going to want to do. We're going to want to basically say anything in this folder is not going to exist, is not going to like be saved inside of this containers folder, but rather will be saved on the host computer. So what you can imagine is that it's basically like, we have this home/Jovian folder inside the container. We're going to want it to almost like a little like trap door or something, like have it really be written to this folder, to a folder here on my host computer. That way anything I write in the container will actually be saved on my host computer, and that way it won't disappear at the end. Okay, so that's our goal, is instead of writing this notebook to the container where it's going to disappear when we shut down the container, we'll write it actually directly onto my host computer. So how do we do something like that? Well, let's shut this down. I'm going to remove this special.md. Okay, and now we'll do docker run, same thing, -p, so we're mapping the port. And then we'll also map, and we have to, it's always the host to the container spot. So in this case, it's going to be, I think it'll be $pwd. Let me see this. And then it's going to be colon. So the same way that we do like a host colon. So this would be the present working directory to /home/Jovian/work. So now this is going to be the location in the container. So the same way I'm mapping an outside port to an inner port in the container, here I'm mapping an outside folder, right, this folder, to an inner folder in the container. Let me boot this up. We go here. It breaks. Oh, because I don't have the 8899. And then if we write something, actually, let's just create a file so we can see it a little better. All right, we can save this too. All right, now what we said was, the way that we set this up was anything written in that home/Jovian/work folder is actually going to like live on our host machine. So when I shut this down, you see that? There they are. Okay? Right? And this is the text that we wrote out. So how did we accomplish that again? We one old menus, right? We map the port, host port, container port. Then we also map the folder, right? Host folder, present working directory, to the container folder. So anything written in this container folder will actually be there. What's nice about this is that, like anything, even if this lives on our host machine, the next time we boot up our container, it will be reading this folder, work, will really be reading from this folder, my practice folder. Okay, so we'll see that. Remember, this folder has these two files in it. Hello, IPYNB, let's create another one, whatever.md, right? And let's now boot this up. Here we're saying basically, instead of it just being this container folder, don't use this, read instead from the present working directory, which is this practice folder. So we should see the whole contents of that there. So we go here. Here's work, and now, right, there's those three files. The two that we created from last time and the new one that I put on my host machine. So any changes you make, right, this is going to be, this isn't really, the trick is this is not really writing to the container. This is, we said, kind of when we boot this up, really be reading and writing from this folder instead on my host machine. So, same thing, when I look at this cat, whatever MD, it gets those changes that I just wrote inside the container. Questions about this? me see. But the container is new, right? It's just reading from that exactly right. So every time I boot this up, that's a really good point. So Kamal, is pointing out like every time I boot this up, we are getting a new container every single time, but each time we're holding on to, right, we're reading from this folder. So it's the only thing that's persisted is like what's here. Everything else it's a new container each time. Sorry, I do that every time. So you can see that, you'll see the name of the container change each time. So here it's called admiring whatever, and then when we shut this down again, it's going to be called something else. It's called Youthful Williams, but each time it's still reading from that folder, and basically we're holding on to what we want, that folder that we specified. Let's see, other questions? All right. Next thing, so this is called bind mounting. Bind mounting. There's another way, and notice that with bind mounting, you read and write directly to a folder on the host computer. There's a very similar approach, which is just using volumes. Okay? So bind mounting, this is attached directly to the host computer, right? It's just reading and writing to a folder. Volumes is like a little box that lives inside of the Docker ecosystem. So with volumes, it's very easy to use. It's exactly the same, except that instead of like the present working directory specified here, you just can write like literally, and normally the present working directory really starts with like a slash, right? It'll be like slash, the username slash document slash whatever, right? It's like that's bind mounting. With volumes, you'll just literally write out like Jupyter files. You just write out, right there, right? This is not a directory. There's no slashes here, right? There's no like dot slash. There's no slashes at all. So now you do this. This will no longer be reading and writing to a folder on your computer. It'll be reading and writing to this like black box, this volume thing. So you'll see that if I go here and I do this 99, this will now be blank because our volume is new. We just created a new volume, right? So here in work, there's nothing here. But if I do, have this untitled, it's called index, hello from a volume. Okay. You'll see that so we just created a volume called Jupyter Files. You can do Docker volume ls, and see this. There's this new volume right here called Jupyter Files. So now, if I say, hey, have the contents of Jupyter Files point, instead of reading and writing to /work, read and write to this, this black box Jupyter Files. Okay, it will, that's what it will do. And we wrote something inside of here, right? We wrote that new like hello from volume thing. So now same thing, we can boot this up. Just change this to 99. I think I just want to make sure this might not work. Let's do this localhost thing. Yeah. Right, and now we have this hello from a volume. Right, so how do we accomplish that? You just literally put the name of the volume, okay, instead of a path to a directory. Which one is preferred? The volume. Okay, why? Because you don't have to like create a new folder, right? Like this is like contained inside the Docker ecosystem. Like what is a volume? It's literally just a folder like inside of Docker, like a specified folder where all your Docker stuff lives. It's just another folder, but it's like contained. Docker knows about it. It's not gonna, you're not gonna accidentally put something new in there, right? When you're doing something else, you're like, oh yeah, why not just move this file over here? You can't accidentally do that. So that's why it's just safer to work with a volume, right? Because it's lives in the Docker ecosystem. Any questions? Oops, we got questions. Okay. Is Jupyter Files a new folder you created? Well, technically, it's a new volume. This is a volume I created. What is it really? What is a volume? A volume is a folder. Well, it is just it still is a folder that lives on my computer somewhere, but I can't access it. Like there's no way for me to go like cd Jupyter Files. The only way I can like access the contents of it is when I boot up a container, and say, hey, read and write from this. Isn't there a way to have this volume on another device altogether? I have never done that, but I think you can like push a volume up to the cloud somehow if you want to. Yeah. Yeah. But like I've never, like I said, it always is living on a computer somewhere. I think there is a way you can do like the volume push or something.
Just a quick question regarding the advantage of Docker. I'm still trying to understand what is the advantage. Like
Yeah.
considering that we have an application which actually requires some sort of storage, like a folder or volume. In that case, we either we use a volume or folder. We're still sort of confined to one system. So, for example, we are running Docker on EC2. We are still confined to that particular EC2 instance because we are using some sort of storage in there. So now that leads to another point, why we need Docker if there's a sort of a tight coupling between the storage in the EC2 instance and Docker. Like why we just don't directly install some application which we are running through Docker? That's my first question.
Well, is the first question why use Docker at all when we can just start with the EC2?
When we can directly run an application in EC2, especially in the case when we are using some sort of storage in EC2.
Okay.
That application is using this volume of storage.
All right. So if it's like, hey, this is very simple. Why don't we just set this up on EC2? Remember that like you're going to be developing on your local computer, making sure things work there, and then want that to exactly work on your EC2. As things change on your local computer, so you would need to make sure there's like a one-to-one, right? Your environment on your local computer perfectly matches your environment on in your EC2, and that's likely to not be the case, right? And then the other thing is, it's not just your local EC2, like your local laptop, your development environment that has to match the production environment, but everyone on your teams as well, right? Because everyone's coding, we want your code to work on everybody's computer. So Docker, right, is ensuring that these are the requirements, right? These are the environmental requirements, and this is going to be in this isolated space and work, because we're you'll see when we get to images that we're prescribing every step from installing Linux all the way up until we have a working application. So, like keeping that, this environment, locally, this environment on my laptop, on everybody else's laptop, exactly matches the environment on my EC2. That's going to be very hard to do without Docker.
But before Docker, I mean, this is subjective question, but before Docker, still applications used to be hosted, and they're still hosted without Docker. Like, we talk about a common repo which has a file for storing the environment and whatnot. What's stopping that from getting different environments in different systems? Like if we have a common repo from where the CI, CD, or simply we are dispatching the repo into different systems and running that.
But it's not that simple, right? Because you need the right version of the database, you need the right version of Python, you need the right version of any other kind of Bash, right? So, and now let's say you upgrade it. Well, okay, but that now something that works on your computer isn't going to work on the EC2, right? So once there's a difference between the two, now you're allowing for something that works locally to not work in production. So even before Docker, people did something very similar. They wrote out, here are all the steps, and generally they wrote code. There was this tool called Chef, which is like for Ruby, where they would write out like all the steps to set up an environment. That way, it was very similar to Docker, same kind of mentality that like we will write out basically, this configuration of code as code. We will write out everything that's required to get our application running. Install this, install that, not just write it out in text, but write code that sets up our environment perfectly. That way we have this environmental setup and we can just run this script and it will, work on this computer and that, right? So that's very similar to what Docker's doing too, right?
So Docker is sort of enforcing common environments across every system.
Yeah, like, that's the idea.
Even if you wanted to, you can't change because of Docker.
Yeah, I mean, you wouldn't want it, like, you can change the image, like, we'll get to that. But Docker is making sure, hey, we're starting off with this, like, clean environment and then slowly installing things until we get a running application.
Yeah. Mm-hmm.
I don't know if you've ever had any issues when you're working on a project and there's lots of packages and those packages have dependencies and there's like a mismatch between or a conflict between those dependencies. One needs this version, another needs that version, and it just can get very complicated very quickly. And I think that Docker simplifies all of that by saying, no, this one works, and so everybody gets that no matter what, and you can't mess it up. And especially with Python, I think there are just so many libraries and so many dependencies to manage. At least that's the way I think of it.
Yeah, I mean, one thing to point out, Docker started, like, if you look at the base of a Docker image, like, we'll get to Docker images, writing our own. They start from the operating system. They start from, like, we are using this version of Linux. Then we are, installing this. So the same way that we run into these environmental issues with Windows and, versus Mac versus this version of Windows, blah, blah. Like, with the Docker image, you're starting from square one, Can there still be issues? Somehow, yes, even with all that. But it clears up a lot of things. Yeah, it's pretty close. So Narapati says Docker ensures that if it works on your machine, it will work on any machine. That's pretty close. There is still, like, you will see because of these M1 chips and M2 chips with Mac, somehow they do something, I don't even understand it. Somehow they do something different where an image can still break with that, but you can work around it. Hey, Kyle. Yeah, go ahead.
I had a question about bind mounts and how they relate to like hard links and symlinks, and feel free to refer me to the internet, but I did do like a rabbit hole a while ago when I was like thinking about my workflow, taking notes when I was in a project or in class, and I wanted to like sync it with my Obsidian vault and have it live in two places at once. And that's when I kind of discovered bind mounts, because like you can set it up so that that file or folder kind of points to the same data.
Yeah.
And my basic takeaway was bind mounts are kind of like the most robust solution, and but all of these options might kind of like fall apart if you're using some syncing method. And I was very curious when I discovered that it was involved with Docker. So I don't really know what my question is, other than like trying to understand a little bit more if there are nuances between the three. Like I said, also feel free to punt on that.
Yeah, I mean, the one thing I just point out is like, so bind mounts, like, I don't want to get into symlinks, but they're very similar. It's but bind mounts are inside the Docker kind of ecosystem. And the one thing to point out is there's no like, oh, you're writing in this container and now every second we're copying over to the host machine. Instead, it is what you said. It's a pointer. So when you are writing, when you think you're writing to /Jovian/work, you're really writing. It's never even touching that folder in the container. If you're using a bind mount, it is writing directly to your host machine's folder. Okay, it is a trap door to your host machine's folder. Okay, so there's no syncing that has to occur. Same thing. That's why it's
right.
Yeah, right. It works the other way too.
Yeah.
Cool. All right.
Cool.
Yeah. So unless there's other questions, I'll leave it